Agreed.
And on the topic of mermaid diagrams, Steve, I'm going to pass it off to you. You have about, if you give us like a 7 or 8 minute overview of the architecture, or just cover any aspects that you think we haven't in the past.
Yep. So if you could stop sharing, Andy, and then I'll grab it. I know Zoom disappears at the worst time.
Yeah, it's getting it back. It's always there. We go. Found it. Found out where it was hiding. Yeah. All right, you should have it now.
All right, perfect.
And while Steve's getting set up, when he finishes, we are going to jump over to Twitch. We have a great program for you today. Some fun videos. We have the word game, and we have 4 presentations. They're all about 10 minutes long. So I hope you can join us. It's just at that point, it's just watching.
And just for reference, I'm working from the Ortelius architecture blog that we have out there. I have to make some updates to it, so you'll see some things that are out of date. I have some comments that Tony made I need to incorporate, and some of the things that we've learned over the past month as we're going through and implementing things. Normally I go through and show like the overall architecture, but today I'm going to dive into kind of how all the pieces fit together as we go through our microservice architecture. So one of the things that we're doing with this version of Ortelius is we're going to be a pure microservice type of implementation. In the past, we had our current version that we have running is a monolith plus microservices. So the new code that we added, new functionality we added it via microservices, and we kept the monolith around just because it's too much to rewrite with that version. So with the new version coming out, the UI front end is going to probably be Riot.js. And Riot.js is the same stack that Docker Hub is using. So we have, if you look at the Docker Hub, I think it's called desktop or desktop UI, that repo is where the Riot.js code is. So we'll have a good starting point. We'll be able to model off of that type of framework that folks are familiar with. And one of the things that we'll have is we'll be able to, from the UI, create a component version, or we can do the same thing through our CLI. So basically, when we go to say we need to create a new version of a component, we have all this data that has to go with it. We're going to have what's the name of the component, the information about its attributes, like what's the Git SHA, what was the Git branch, the list of users that have contributed to this repo, things like that, the SBOM, all that's going to come across in the JSON for the component version. In order to split out the transactions, we'll still be using an Nginx reverse proxy. And that basically allows us to say I have this URL for the RESTful API endpoint, which microservice does this transaction need to go to? We're going to have about 20 different microservices, maybe a little more. We'll have to see how things play out as we go through and get going here. Thanks to Arvin for going through and kind of priming the pump on those repos. So all the repositories are out there. They all start with SCEC, so Supply Chain Evidence Catalog. So that's going to be the prefix for all of the new microservices. So what ends up happening is the JSON payload comes in, gets routed to the proxy to the right microservice, and then the microservice is going to have the business logic of how to deal with that JSON payload. One of the things that we've recognized is a lot of the data is very redundant. So when you look at an SBOM, you go through and just you make a small coding change to your Node.js program, you fix a header file, like a header on a page or something like that, that your JavaScript code is changing, but all the packages that you're depending upon hasn't changed from build to build. So that's where the redundancy comes into play. And because of that, we have to take all of our whole big JSON payload and transform it into a normalized version. What that means is we go through and remove all the redundancies. So that allows us to persist just things once. So there's actually, this says Python. We've actually changed over to Golang. We found that the Python libraries for some of the stuff we needed to do on the back end weren't there, so we changed over to Golang. And there's a Golang reusable module that allows us to go ahead and do this normalization of the JSON payload. From there, that's going to get passed over to our database abstraction layer. And that's going to allow us to go ahead and persist into the Rango database. The Rango, we chose this one because the Rango is not only a graphing database, but also it provides the being able to store documents as well. So like a MongoDB. So it's really easy in a Rango to do both. So you can take a document and then go ahead and graph the document. So you have the high performance of the dependency relationships. And this is why I was asking Andrew about the dependency hierarchical versus bidirectional. We'll be able to do the bidirectional on the Rango side. One of the things that we'll need to do is to persist that normalized JSON into Rango. And then we're going to come back and then do a second persisting into the NFT storage. Now, on this part, the NFT storage, the ledger, this will also, we'll be able to swap out and parse as well in this part. These three boxes here will be combined into a microservice. So initially we thought we're going to keep it all within in this main microservice, but after looking at the performance and stuff like that, this transaction here persists to the long-term storage. That's going to be off to a second microservice. And the reason being is we found the IPFS storage can be pretty slow. You're talking several seconds to persist something, and when you're going and trying to persist, hundreds of objects all at once, it's just too long of a delay for the UI. So the microservice will actually go persist into the long-term storage in the background, and we'll have to do some flagging back in the Rango side to indicate whether something has been persisted or if it's kind of like in this weird caching mode still that we have to deal with. Once we have all that persistence coming back, we just keep on returning all the way back to the UI saying that we have everything up to date. Now, one of the things that we will have, like I said, the microservices will be tailored to be specific around an object. So in this case, we're doing component version. We'll have a microservice for an application version. So that's where the logic will be focused around a particular object for the microservices. And like I said, we have about 20 different microservices that we'll be going through and working on. So if you're interested, because these are small microservices, the code base is pretty small, a couple hundred lines long, and it's easy to understand when it's a small code base like that. You're not overwhelmed with all these other functions in your way and stuff like that. So if you're interested in working on a microservice, the issues are out there underneath the Ortelius organization. They're tagged with the bounty, and then whether they're going to be the front end UI piece, DevOps pieces, backend pieces. You'll see the different tags we have out there to allow you to pick and choose which services to work on. So with that, I'll just take any questions if anybody has anything, and if not, we'll go ahead and roll on to the presentations.
And just as a clarification for some of you who may not know, when Steve references the tags under Git that are listed as bounty, those are ones that you can get paid for based on the XRP ledger grant that we received. So
yeah, and there's
to do that, but that's what he's talking about.
Yeah, and there's a blog post out there on how to set up your GitHub account to receive the payments and stuff.